If you don't like engineering but still want to know cool stuff, stick around to find out how we saved the Leaning Tower of Pisa. The Leaning Tower of Pisa has been leaning since its construction started in 1173. This iconic structure, known for its unintended tilt, has fascinated people for centuries. Originally designed to be a freestanding bell tower for the cathedral of the Italian city of Pisa, it began to lean during its construction due to a poorly laid foundation and loose substrate that has allowed the foundation to shift direction. The lean was caused by uneven soil under its foundation, more sand on one side, more clay on the other. This uneven distribution of soil created a situation where one side of the tower began to sink faster than the other, leading to the characteristic tilt that we see today. Over the years, various attempts were made to correct or stabilize the lean, but it wasn't until the late 20th century that a successful solution was found. By 1990, the 5.5-degree tilt posed a collapse risk. The situation had become so dire that the tower was closed to the public for safety reasons. Engineers and historians alike were deeply concerned that this World Heritage Site might be lost forever if immediate action wasn't taken. So, how did they fix it? The solution wasn't straightforward. It required a combination of historical knowledge, modern engineering techniques, and a bit of creative thinking. The first step was to understand the exact nature of the problem, which involved a detailed analysis of the soil and the tower's structure. First, a team of experts assessed the problem using boreholes, soil tests, and computer simulations. These tests provided crucial data about the composition and behavior of the soil under the tower. The computer simulations helped engineers visualize how different solutions might affect the tower's stability. They temporarily stabilized the tower with a concrete ring and 600 tons of lead counterweights. This was a critical step to ensure that the tower didn't lean any further while a more permanent solution was being developed. The counterweights were placed on the north side of the tower, the side opposite the lean, to counterbalance the tilt. But that was just the beginning. The temporary measures bought the engineers some time, but they needed a long-term solution to ensure the tower's stability for future generations. The challenge was to correct the lean without compromising the structural integrity or the historical value of the tower. An initial attempt to replace the weights with ground anchors failed. Turns out, the tower had a sneaky structural connection with its walkway. This unexpected discovery meant that the engineers had to go back to the drawing board and come up with a new plan. Back to the drawing board, the team of engineers and experts had to brainstorm and evaluate multiple potential solutions. They considered various methods, each with its own set of challenges and potential risks. They rejected two permanent solutions, pumping groundwater and using electroosmosis. Groundwater pumping was deemed too unpredictable as it could lead to further instability in the soil. Electroosmosis, a technique that uses electrical currents to stabilize soil, was also ruled out because the soil's high conductivity made it ineffective. Groundwater pumping was too unpredictable and electroosmosis just didn't work with the soil's high conductivity. Finally, they tried under-excavation. This method involved carefully removing soil from the higher side of the foundation to gradually reduce the tilt. This meant carefully removing soil from the north side, where the ground was higher. The process had to be done slowly and meticulously to avoid causing any sudden shifts that could destabilize the tower. They drilled 41 holes and took out 70 tons of soil. This painstaking process required precision and patience, but it ultimately proved to be the key to stabilizing the tower. This reduced the tilt by about 0.5 degrees, enough to make it safe while preserving its iconic lean. The tower's tilt was reduced to a safer angle, ensuring that it would remain standing for many more years to come, and there you have it. The successful stabilization of the Leaning Tower of Pisa is a testament to the ingenuity and perseverance of engineers and scientists. The Leaning Tower of Pisa still leans, but it's now stable and safe, all thanks to some brilliant engineering. Isn't that cool? Next time you see this iconic structure, you'll know the incredible story behind its preservation.